All right, I wanted to make a quick video showing you how to use a TI-84 or a similar graphing calculator to find zeros on a function. And the reason why this might be useful is because sometimes we are given a graph that's not a function. And so we want to figure out where the slope is horizontal. We have a horizontal slope, like a horizontal line here. I didn't mean horizontal slope, I meant a horizontal line, which means the slope is zero. So like up here or down here. Or we want to know where we have a vertical tangent line, which is where the slope would be undefined. So that would be here or here. So if we want to figure out where the slope is zero, that means a horizontal line, or the slope is undefined or a vertical line, then it is helpful to know in the original equation if the numerator is zero, when the numerator is zero, or when the denominator is zero, when we have dy over dx. So I want to show you how to use the equation editor to do that. So to graph this, I'm in a mode called polar mode. I can change that by going to mode and see it's in polar right now. I can change that to function like this and hit enter, and that's the mode we're more familiar with. So if I go to function mode, and by the way, these equations here are not correlated with the graph you just saw. The graph you just saw is a circle. It's just stretched out because of the x-axis and y-axis are not the same. But that was a circle. This has nothing to do with that circle. So I put these values in ahead of time, and what this represents here is the numerator of another graph, and this right here represents the denominator of another graph. But I can, the numerator and denominator for dy over dx. So that means this right here, since it's the numerator, when this is zero, that's when I'd have a horizontal tangent. And when the denominator is zero, that's when I would have a vertical tangent. So anyway, I just want to show you how to find zeros using your graphing calculator. So I basically type in this equation here, x minus 1 times x minus 2 plus x times x minus 2. And if I keep scrolling over, plus x times x minus 1. So if I multiplied all this out, my highest degree would be a power of 2. X squared would be my highest degree. So I know that this is going to come out to be a quadratic or a parabola. And so notice that this one is black and this one down here is not. So if I hit enter, that basically means it graphs both of them. So if I go to graph, you'll see both graphs together, a blue one and a red one. But I only want to look at one at a time right now. So I'm going to go ahead and hit enter over the equal sign. And now it's turned off and it won't graph it. It'll only graph this first one. So this first one is a quadratic. So if I go to graph, it looks like this. Now what I want to do is kind of want to zoom in on it. And I want to know when this hits the x-axis. Because when this hits the x-axis, that's when that particular equation, which is the numerator of my dy over dx, when that particular equation is equal to zero. So I'm going to change my window to make it something more zoomed in. So I'm going to make x min 0 and x max 2, because I think all the zeros happen between 0 and 2. I graph it, and you can see here's a 0, and here's a 0, and they're on either side of 1. So I don't know exactly what they are. And solving it analytically is sometimes easy if things factor well, but a lot of times they're not easy. You have to use a quadratic formula, and it's a pain. So the graphic calc is great because we can get it right away. So as we know, we can hit trace and we can find values, and I can try to actually estimate it by keep zooming in and estimating that way. Be like, it's somewhere, it looks like somewhere around 0.39, I don't know, 0.4. I don't know exactly what it is, 0.4, whatever. I'm getting close to it, but I don't know exactly what it is. So to figure out a very good estimate, better than what I'm doing right now, we go back to calc, which is the second calc button. And you'll see there's a thing called zero here. So if I scroll down to zero, hit enter, it's going to ask me a left bound. And so I'm going to go to something that's clearly on the left side of the zero and hit enter. And then I'm going to go to something that's clearly on the right side of the zero and hit enter. And so then it knows what to focus in on because there's another zero over here. So it knows to focus in on this area. And it's going to look for the zero between this vertical line, this vertical line, this x value, and this x value. And then it wants me to come up with a guess. So what I'm going to do is I'm going to trace over to where I think it is and hit enter. And it's going to follow a method to find the zero much more accurately than I can. And that's what it comes up with, 0.4226. All right, so that is how you find a zero. I can do the one on the other side too. So I can go back to calc, which is blue trace button. I can go down to zero and hit enter. I can go over to this guy. You can scroll over there and pick something that's clearly on the left of the zero and pick something that's clearly on the right of the zero. And then I can go to where my estimate is and hit enter, and it will give it to me more precisely, 1.577. All right, so that's how you can find zeros using your calculator. I want to show you another one because this one was a little bit easier since it's quadratic. So if I go back to y equals, I'm going to turn off this one, which was my numerator. So basically, those two zeros I found would be the place where I would have a horizontal tangency because this is the numerator of my dy over dx. And then if I hit enter here, it'll now graph this one. And this one was the denominator of my dy over dx. So this is where I would have a vertical tangency. All right, and I'm going to go back to the graph. Okay, I can't see it all very well. So I'm going to go back to zoom and scroll down to zoom standard. And so this is what it looks like. So the zoom standard, it's a cubic, which I could have probably predicted because going back to y equals, you see x squared times x is a cubic, x squared times x is a cubic. So all the highest terms are cubic. So it's not a surprise that the graph ends up being a cubic. I can see that everything seems to happen between -1 and 2. So I'm going to change my window to -1 and 2. And then graph it. And I should see my three zeros. In a cubic, you'll have three zeros, 1, 2, 3. And then I can do what I did before, second calc. And I'm going to choose a 0. And I can choose, there's 3 of them here. So I can choose this one here if I want to, right here, or I could choose that one or that one. I'll go ahead and do this one right here. So I pick something that's clearly on the left, and I pick something that's clearly on the right. And then I can pick an estimate. And what I'll do is I'll follow an algorithm to find the estimate more accurately. In this case, it's exactly 0.5. And so this one, maybe if they're all come out that clean, you can factor it to get those zeros. But that often doesn't work. And I don't think it works on this one either. It's just this one comes up exactly 0.5, but the other two come out to be very long decimals and probably irrational numbers. So anyway, that's how you find zeros using your graphing calculator, your TI-84 or something similar.